So our first example in section 7.1 part 2, sorry, this is part 2, starts off by listing the events inside a sample space. So the sample space S for sample space consists of A, B, C, D, E, and F. So these are outcomes. So what I'd like you to picture is a round piece of cardboard that's divided into 6 equal-sized sections that are labeled A through F. You got a plastic spinner that you basically spin, and it would land on different outcomes. So event E is that it lands on either the A or B sections. The event F is that it lands on A, D, or F, and the event G would be that it lands on B, C, or E. So those are the different outcomes for that spin. So we want to find the events. So part A is asking us to find E union F. And again, remember that's the symbol for union. And that is everything in both sets. So E union F would be made up of A, B, D, and F. I've simply listed everything that makes up A and F together. So A or F. Part B is asking for E intersect F. So E intersect F, that's the events they have in common. Well, the only thing in common to A, to E, and F is the event B. No, the event A is the only thing they have in common. That's their overlap. Part C is asking for F complement. And to make our lives easier, what we're going to do is we're just going to go find all the complements because of the rest of the problem. So if E contains AB, what's outside of E is C, D, E, F. So E complement is made up of C, D, E, and F. F complement is everything outside of F. Well, F contains A, D, and F, so we need the B, C, E. So that's everything that's outside of F. And then G complement would be what's outside of G. So if I take out the B, C, E, I'm going to get A, D, F. Okay. So to answer part C, F complement, we just did it. It's B, C, and E. Part D is asking us to find E intersected with G complement. So here's E, here's G complement. What do they have in common? Well, the only thing they have in common is, again, the A. So intersection, what they have in common is A. Part E on that problem is asking us to find E complement, which we already did. So we'll just copy it down. It's C, D, E, and F, everything that was outside of E. Part F is asking us to find F complement intersected with G. So here's F complement, here's G. Wait a minute, they're the same thing. So the answer would be B, C, E, or I could list either F complement or G and still be correct. I could list it as a set versus the roster. Part G is asking me whether or not E and F are mutually exclusive. Well, no, they're not. And the reason I know they're not is because they have an overlap. So they are not mutually exclusive because their intersection is not empty. So the answer here is no. And that's because E intersect F is not empty. They are not mutually exclusive. Part H is asking whether or not E union F and E intersect F complement are mutually exclusive. Well, we already figured out what E union F is. It's listed right here. It's the A, B, D, F. We did that part. E intersect F complement we didn't do, but we can figure it out pretty quickly because we have F complement and I want to intersect it with E. Sorry, E. E and F, well, the only thing they have in common is B. Okay, so if these guys have some elements that are in common, they're not mutually exclusive. So again, the answer is no, because the intersection is not empty. So to be mutually exclusive, their intersection has to be empty. They need to be disjoint. And finally, I is asking us whether or not E and F are complementary. Well, in order to be complementary, the two together would need to create the sample space, our universe, basically. So they are not complementary. They are not complements to each other because E complement does not equal F, and F complement does not equal E. So E complement is that, it's not equal to F, and F complement is this, it does not equal this. So because their complements are not equal to the other set, they are not complementary. That should remind you a lot about chapter 6, and also some stuff that's new, mutually exclusive, the idea of complementary. Now let's do the next example. So example 2 is asking us to let S be any sample space, and E, F, and G are any three events associated with that experiment. What we're going to do is translate the words into symbols. So describe the events using the symbols union, intersection, or complement. So part A literally says the event E and or F occurs. Now what I want you to do is concentrate on this, because the and or is your author's notation. I think of this as the event E or F, and because it's an or, I know that that is a union. So the translation of this statement into symbolisms or notation is E union F. Okay, part B says the event that both E and F occur. Well, because this one's just an and, we know that this is marking the intersection. So the and means the intersection. The and or, concentrate on the or to get the union symbol. Part C says the event that E, but not F, occurs. So to help you with this one, I'm going to go back to the Venn diagram. So here's E, here's F. We want E. E is made up of this region and this region, but not F. So not F would be this region, sorry, and this region. So the only one that has checks for both pieces of information is this guy, and that's just E complement. So that would be E com, sorry. So to get to that region, we're going to do E intersected with F complement. So E was the two checks that we did first. F complement, or the two checks we did last. We're looking for the intersection, which would be right